Hello everyone, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakimi bin Muhammad Radwan and my supervisor is Dr. Nur Fawazi bin Muhammad Nuruddin. My title will be Modified Laminated Rubber Bearing of Building Frame Using Finite Element Analysis. Let's go to our presentation. Before we proceed further, first I will introduce about the laminated rubber bearing, otherwise known as elastometric bearing of a composite elastomer and a metal layer. It can be supporting a massive structure such as building during an earthquake. The function of it is to reduce force during an earthquake so that the force will be absorbed by the lead rubber bearing so that the building will not receive as many damage as a building without lead rubber bearing. The lead rubber bearing works on the base isolation and limits energy transfer from the ground to the building structure. The rubber layer acts as a spring because the rubber layer is very soft horizontally and very hard vertically. The hardness of the lead rubber bearing is achieved by having the rubber layer reinforced by the steel layer. This will allow the lead rubber bearing move vertically while supporting high axial load. As example, as you see from the picture, the lead rubber bearing will be placed under the footing of the column of the building. So for my project, I will be investigating lead rubber bearing. Next, for the objective of my final project, the first will be to explore the effect of deformation and also stress distribution on the structure. And the second one is to optimize the design of the laminated rubber bearing, lead rubber bearing. First, we need to find the effect of deformation as stress distribution, and then from the data collected, we can now and then optimize the design of the LRB. For the method of finding this objective, of attaining the objective, I will be using finite element analysis of using Abacus simulation software. For the methodology of my final year projects is number one is I will be using force and displacement on the lead rubber bearing using vertical load and then finding the result of and finding the actual result on the lead rubber bearing. For the second method, I will be using real earthquake data on the lead rubber bearing to see the effect of lead rubber bearing during an actual earthquake. Next, for the further studies, as you can see from the picture, the lead rubber bearing will be placed on the bottom of the structure, and then the earthquake data will be used to find the effect on the building structure and also on the lead rubber bearing structure. Next, we move on to the result of my final year project. The picture you can see on the left side is the stress distribution of lead rubber bearing during the first stage of the methodology, which is to use displacement and also vertical load onto the lead rubber bearing. Next, the picture from the right is the result from the first methodology, which is, as we can see, when the force exceeds 300 kilonewton, we can see that the displacement happen toward the right side. When the force and displacement also reach the maximum, the laminated rubber bearing will move toward the left side until it reaches the maximum displacement and force. And when we reach the maximum displacement on the left side, it will go back to the right side. And for the second method in my methodology, I could not proceed because of the error in Abacus software, and also for the further studies, uh, I will be for further studies we can use the lead rubber bearing on a steel structure like the previous slide to conduct the effect of lead rubber bearing during an actual earthquake. Next, for the conclusion, the finding for the analysis can be concluded as follows. The analysis using Abacus shows that as the force increases, the displacement will also increases. After it reaches maximum force and displacement, the laminated rubber bearing will displace to the left side until it made a circle. Unfortunately, this is the only initial analysis, and there is not any adjustment made to the laminated rubber bearing because of the error on Abacus software. That is clearly my fault, and for the next further studies, we can use the lead rubber bearing onto a steel structure and also observe the effect of earthquake data on the structure, the combination of steel structure and lead rubber bearing, to observe the effect of lead rubber bearing towards the combination of the said structure. And lastly, I would like to thank Dr. Fauzi for his guidance throughout my final year project, and also my parents and also my friends that helped me during this time. Thank you very much. That's all for my presentation.